Welcome back. In this session, we'll continue the discussion on inverse Laplace transform, and we'll continue if we have x of s and x of s contains a term of quadratic form. So if we have a term like s square plus as plus b, how do you write the inverse Laplace transform? This time we'll see if the roots of this quadratic term are complex roots, right? So to illustrate this, let me take an example. So let's take an example. Let's suppose x of s is simply s plus 3 divided by s into s square plus 4s plus 5. Let's suppose this is the x of s. So our goal is to find x of t. So the method that we have been using is the partial fraction expansion. And in partial fraction expansion, what we do, we write this in the form of a1 by s plus a plus a2 by s plus b plus a3 by s plus c, and so on, depending upon the order of x of s. Now here is 3, here the order is 3, so we will have 3 terms. So what we'll do, we'll try to bring s square plus 4s plus 5 in this form. We'll try to bring it s plus a and s plus b form. Okay, so to do that, we'll find the roots of this quadratic term. So how do we find the roots of this quadratic term? If it is ax square plus bx plus c, we write x 1 comma 2, means the two roots will be simply minus b plus minus b square minus 4ac divided by 2a. And if the value of x1 and x2 is alpha, so x1 is alpha and x2 is beta, then we say we can write ax square plus bx plus c can be written as x minus alpha into x minus beta, right? We already learned this from the basic math classes, so we can do it like this. So to bring this s square plus 4s plus 5 in this form, what we'll do, we'll find its roots. So we have s square plus 4s plus 5. If we compare it with this, so we can write the two roots of this is minus 4 plus minus 4 square is 16 minus 5 into 4 multiplied by 1 because a is 1. So 2 times 1. This is equal to 16 minus 22. So this is 4 under root of minus 4 divided by 2. Now, if we have a root of a minus quantity, we know that can be written as g, right? So we can write it as minus 4 plus minus under root of minus 1 multiplied by under root of 4 divided by 2. Now we know under root of minus 1 is simply g. This is the complex number. So what is under root 4? That's equal to 2 divided by 2, right? So then we can write dividing the two terms by 2, so it will be 2 plus g. So the values of s1 and s2 is simply s1 is minus 2 plus j and s2 is minus 2 minus g. Now, if we have a complex root, the other will be conjugate of that. You can check s2 is conjugate of s1 or s1 is conjugate of s2, right? What do I mean by conjugate? Yes, means the magnitude is same, only if one has plus j, the other will be having minus j, right? So that in other words means this s square plus 4s plus 5 can be written as s minus of this, so minus 2 minus j, right? When you say, and this is alpha minus alpha, right? If you say minus this, so it will be plus 2 minus j multiplied by s minus 2 will become plus 2 plus j, right? So this is equal to, this is s square plus 4s plus 5. So you can express it as s square s plus 2 minus j s plus 2 plus j. So what we do, we'll substitute it back here. So we have x of s, which is equal to s plus 3 divided by s into s square plus 4s plus 5. This can be written as s plus 3 divided by s plus s, here we have s into s plus 2 minus j s plus 2 plus j. Okay, now we can use the partial fraction expansion. That means s plus 3 divided by s into s plus 2 minus j, s plus 2 plus j, which is x of s, can be written as a1 by s plus a2 by s plus 2 minus j plus a3 by s plus 2 plus j, right? So what's our goal? Our goal is to find a1, a2, and a3. So this is the partial fraction expansion of this. So this is the partial fraction expansion of this. So our goal is to find a1, a2, and a3. So to find a1, a2, a3, what we'll do, we'll multiply both sides by this denominator. We'll multiply both sides by this denominator, that is s into s plus 2 minus j, s plus 2 plus j. So we'll multiply both sides by this. So once you multiply on left hand side, you will be left with s plus 3, because the numerator and denominator will get cancelled. That is equal to a1 s plus 2 minus j plus a2 s into s plus 2 plus j, right? So from this s will get cancelled. Okay, I forgot the one term here. So it is s plus 2 plus j, right? So if you multiply both sides by this term, s and s will get cancelled. You will be left with this from in the first term. In the second term, s plus 2 minus j will get cancelled. So you will be left with s into s plus 2 plus j. Plus in the third term, you will be left with s into s plus 2 minus j. Once you multiply both sides by this, s into s plus 2 minus j, s plus 2 plus j, right? So our goal is to find a1, a2, a3. So what we'll do, we'll make the two terms at a time equal to 0 and find the other. So what we'll do to find a1, what we'll do, we'll put s equal to 0, because there we have s, here we have s. So once we put s equal to 0, so it will be 0 plus 3, that is equal to a1 times 2 minus j, 2 plus j, right? So it is 3 a1. So we know a minus b, a plus b, that is equal to a square minus b square, is 2 square minus j square. Now 2 square is 4, j square is minus 1. So that will be plus 1. That means a1 is simply 3 by 5. So we have found the value of a1. Now to find a2, what we'll do, to find a2, we'll put s equal to, what we'll do, we'll put s equal to minus 2 plus j. Okay, so once we put s equal to minus 2 plus j, this will be 0, this term will be 0, and we'll be left with only this term. So what we get from this, so put s equal to this, equal to 0 plus a2, s is minus 2 plus j, and then it is minus 2 plus j plus 2 plus j plus 0, because this third term is also equal to 0. So okay, I forgot 3 here, so there is also 3, right? So it will be minus 2 plus 3 is 1 plus j, that's equal to a2 minus 2 plus j, then this is minus 2 cancels, it is 2j. So that means this is simply a2 minus 4j, 2 2's is 4, so it is minus 4j. Then when you multiply j by 2j, it will be 2j square, that is equal to minus 2. So that means a2 will be simply equal to 1 plus j divided by minus 4j minus 2. All right. So to bring it in a plus bj form, what we'll do, we'll do the rationalization. What we do, we multiply numerator and denominator by, if it is minus j here, we'll multiply it plus j. So we'll multiply it by 4j minus 2, 4j minus 2, right? So this is referred as rationalization. So if this is minus 4j here, we'll do it plus j like that. Okay. So if it is a by a plus bj, we'll multiply the numerator and denominator by like this. So in the denominator, we have a plus bj, we'll multiply the numerator by a minus bj or jb and a minus jb, because we want to eliminate the j terms in the denominator. So if you simplify this a little bit, what we'll get? So it will be 1 plus j into 4j minus 2 divided by, so it is a minus b, a plus b. Sorry, this should be, yes, a plus b. Here a is minus 2, b is 4j. Okay, so let me rewrite this first so you understand this. So let me rewrite this so that you understand that this is in the form of a plus b and a minus b. So 1 plus j, then I will say this is minus 2 plus 4j, right? I wrote the this real part first. So this is minus 2 minus 4j, then minus 2 plus 4j. Right now, the denominator you can see is in the form of a minus b, a plus b, where a is minus 2, b is 4j. Okay, so first multiplying the numerator, so it will be minus 2 plus 4j minus 2j minus 4. Why? Because j multiplied by 4j is 4j square, j square is minus 1 divided by 2, so it is minus 2 whole square, because a minus b into a plus b is a square minus b square. So it is a square minus b square 4j square. So this will be simply minus 6. Have I done it correct? Minus 6 plus 2j. Please check it. Have I done it correct or wrong? Is this correct? Have I done it correct? Oh, 2. Okay, have I forgotten any term here? S plus 2. The a2 is simply minus 2 plus j. Have I done anything wrong here? Please check the calculations one more time. Let me check the calculations. Once I put s equal to minus 2 plus j, so it is 2 and 2 will cancel. J will be 2j, so it's correct. Okay, let me write. So it is 4 plus 16. Okay, I hope I'm correct. Please check it yourself. So it is minus 6 plus 2j divided by 20. That is equal to a2, and a2 is simply, so it is 6 divided by 20, which is equal to 6 divided by 20, which is equal to 0.3, plus 2 divided by 20, which is equal to 0.1 j. So this is our a2. Now we have found a2. Finally, we need to find a3. So to find a3, what we'll do? To find a3, we'll put s is equal to minus 2 minus j. So when we put s equal to minus 2 minus j, this term will be 0 and this term will be 0. So when we put s equal to minus 2 minus j plus 3, that's equal to 0 plus 0, because first two terms will be 0, then a3 times s is minus 2 minus j, so it is minus 2 minus j multiplied by s is minus 2 minus j minus 2, so we have plus 2 here minus j. All right, so how much is this? This is 1 minus j, that's equal to a3 into minus 2 minus 2j, sorry, not minus 2j, minus j. So it is minus j, not minus 2j. So this is 2 and 2 will cancel here. We will be left with minus 2j. So this is 1 minus j, that's equal to a3 minus 2. So it will be plus 4j, minus minus is plus. So it is plus 2j square. Plus 2j square is minus 2 simply, because it will be minus minus is plus 2j square. J square is minus 1, so it will be minus 2. Okay, so it will be minus 2 simply here because j square is -1. Now that means A3 is simply 1 minus j minus 2 plus 4. What we want to do, we want to bring it in the form a plus j. So what we'll do the rationalization minus 2 minus 4j. So if it is plus 4j here, we'll multiply it by minus 4j. That's how we do the rationalization. Okay. So if it is, you can see it is plus 4j here. So we'll say it is minus 2 minus 4j to eliminate the this j term in the denominator. That's the goal here. This is referred as rationalization in complex numbers. So now this is minus a plus b, a minus b, where a is minus 2, b is 4j. So it will be a square, that is minus 2 square minus 4j whole square. Now multiplying the numerator side, so it is minus 2 minus 4j plus 2j minus minus is plus, then 4, so it will be minus 4. Please check the calculations one more time yourself. Okay, this is 4 plus 16, right? So it will be 16 j square is minus 1, so it will become plus 16. So this is minus 6 minus 2j divided by 20. So that will be same as, okay, sorry, here is minus. Okay, I forgot to write minus here because it is minus 6. So it is minus 6 divided by 20. That's again minus 0.3 minus 2 by 20 is 0.1 j. All right. So what is A1, A2, and A3? A1, I think, was equal to 3 by 5. A2 will be equal to minus 0.3 plus 0.1 j. A3 is minus 0.3 minus 0.1 j. All right. So this is these are the residues of this partial fraction expansion. Now, important observation here. Please pay attention. Very important observation here. If A2 is a minus bj, then the other one, A3 or A1, will be simply the complex conjugate of A2. Complex conjugate of A2 means simply A2 will conjugate of this will be replacing j by minus j, so it will be a plus bj. Now you can observe here, A2 is minus 3 plus 0.1 j. You can check A3 is simply minus 0.3 minus 0.1 j. So it is the complex conjugate of this. That means A2 is simply complex conjugate of this. So in other words, if you have found one, you don't need to find the other one. Okay, that's the observation. So if you have found A2, you can write A3 directly as complex conjugate of A2. Okay, you can write the A3 as complex conjugate of this. So that means A3 is complex conjugate of A2, right? So if you have found one, you don't need to find the other one. So now our x of s, which is equal to what was the expression, if I remember it correctly, s plus 3 s into s plus 2 minus j, s plus 2 plus j, which we expressed it as a1 by s plus a2 by s plus 2 minus j plus a3 by s plus 2 plus j. Now instead of a, you have here 2 minus j, and here you have 2 plus j. Okay, because our goal was to express it in the form of 1 by s plus a. Here a is 0, here a is 2 minus j, here a is 2 plus j. Okay, that was the goal. Okay, substituting the value of a1, a2, and a3. So a1 is 3 by 5. Let me check one more time. Yes, I think it is 3 by 5. It's not 3, it is 3 by, yes, it is 3 by 5 divided by s plus, what is a2? A2 is minus 0.3 plus 0.1 j. 0.1 j divided by s plus 2 minus j plus a3. A3 is minus 0.3 plus minus 0.1 j divided by s plus 2 plus j. All right. So now we can write the inverse Laplace transform of this, right? We know the inverse Laplace transform of 1 by s plus a is simply e to the power of minus at u of t. So based on this, we can write the inverse Laplace transform of this. The inverse Laplace transform 1 by s is simply u of t, right? So inverse Laplace transform of 1 by s plus 2 minus j is simply e to the power of minus 2 minus jt. Same way, the inverse Laplace transform s plus 2 plus j is simply e to the power of minus 2 plus j. So substituting these here, we'll get x of t. So x of t will be simply 3 by 5 u of t plus 0 minus 0.3 plus 0.1 j. So inverse Laplace transform of this term will be e to the power of minus 2 minus j t plus minus 0.3 minus 0.1 j to j here, e to the power of minus 2 plus j. Okay. Now simplifying the terms a little bit here. Okay. So if we simplify the terms here, now you can see there is e to the power of minus 2t here. There is e to the power of minus 2t here. So I will take it out. So with this, okay, I forgot u of t. There is also u of t. Huh? There is u of t here. It's u of t because inverse Laplace transform 1 by s plus a is e to the power of minus 80 u of t. So it is 3 by 5 u of t. Then plus, I will take e to the power of minus 2t common. So what will be left with? Minus 0.3 plus 0.1 j e to the power of plus jt, right? So it will minus minus is plus jt plus minus 0.3 minus 0.1 j e to the power of minus gt because e to the power of minus 2t we took common from. So we'll say 3 by 5 u of t plus e to the power of minus 2t. Now, here we have minus 0.3 minus 0.3. So we'll take it common. We'll say minus 0.3 e to the power of plus jt plus e to the power of minus jt, right? This and this from this term. Then we have the j term. So it is 0.1 here. J, let me write it e to the power of jt minus e to the power of minus gt. Okay, I hope I have done it correct, right? Here we take minus 0.3 common, then we'll be left with e to the power of j and e to the power of minus gt, right? And here we take 0.1 j common, so we'll be left with e to the power of jt, e to the power of gt. Okay, so 3 by 5 u of t plus e to the power of 2t. All right, so this is right. We can express it like I can write it 0.6. Okay, multiplying the numerator and denominator by 2. That's what I did. So I multiplied the numerator and denominator by 2, right? So here we can write it 0.2 j. What I will do instead, what I will do, I will say this is minus j to the numerator and denominator, and I will write it as 0.2. And j I will take in the denominator side, so it will become minus j. Okay, so it will be minus j, and that minus is here. Okay, I will tell you what I did. I multiplied the numerator and denominator by 2j. That's what I did. So it is 0.2 j square is minus 1, so it is 0. Minus 0.2 like this. Okay, now so x of t is equal to this. Then we say x of t is 3 by 5 u of t, and remember there is u of t also. Okay, there is u of t with the terms. Actually, I forgot that there is u of t here. U of t. So let's say u of t we took common from this like this. Okay, so it is e to the power of minus 2t. What is this? E to the power of j theta plus e to the power of minus j theta. It is simply cos divided by 2. It is simply cos theta. So it will be minus 0.6 cos of t simply. And this is minus 0.2 e to the power of j theta minus e to the power of j theta divided by 2j is simply sine theta. Sine theta is simply sine t of t. So this is x of t. This is when the two roots of the quadratic term are complex. So this is very, very important case, right? So this is very, very important case. Now, based on we have solved the problems on the other cases, and it is very easy. But what we'll do in the next session, we'll solve problems, network problems, when the roots are complex, when the roots are complex, okay? So if the roots are complex, we'll solve it there, okay? So we'll solve one example of networks based on this, when the roots are complex, okay? So we'll find the solution of the network problems when the roots are complex, all right? Where we'll encounter this. These we have already seen in the classroom, so we don't need to spend time on this, right? The other two cases, when the roots are repeated or when the roots are distinct. When the roots are distinct are the repeated roots. We have already seen the example so much, but this based on this we'll solve one per network problem. So see you in the next session.